Okay, so we'll continue with section 7.2, part 2, number 34. Test the claim about the population mean at the level of significance alpha. Assume the population is normally distributed. The claim is that the population mean is greater than 22, the level of significance is 0.05, and the population standard deviation is 1.2. So they're giving you the sample statistics, they're giving you the X bar and the sample size, and then you're asked to make a decision. But before we answer any of those, we need to go to through the hypothesis test. So the null hypothesis, we have to set up the null hypothesis and we have to set up the alternative hypothesis. So if you notice in this one, the population mean in the claim is greater than, it doesn't have an equal sign, so I will assign that to the alternative hypothesis. And then the null hypothesis will be the complement of greater is less than, and always with an equal bar. So they're telling you that the alpha is 0.05, but we don't have the z-score. So if you don't have the z-score, but they're telling us that it is based on this, it's a right tail test. So we're going to, based on the alternative, we're looking for a right tail test. So we're going to have to find the z-score for this, but since we have the level of significance is 0.05, the level of significance is 0.05, and this is a right tail test, so that will mean that your z-score is 1.645. So that this is your z-score. So once you have your z-score, all we have to do is look for the area in order to find the p-value, the area under the curve. So the p-value for 1.645, 1.6 and 4.5, it is between 4 and 5. So it is 0.9495, 0.9505. It doesn't matter what you use. We can use 0.9505. So your p-value is 0.9505. And you're going to compare that 0.9505, that's the p-value, compare with alpha, that is 0.05. So you have 4 decimal places and 4 decimal places here. So the p-value, well, actually the p-value, it's my mistake, it's going to be 1 minus, because remember, it's the area. The area to the left is the one that we got from the chart, from the z-score table. So 1 minus 0.9505 will give me an area of 0.0495. So my p-value is 0.0495, and I'm comparing that with 0.500. So this is less, because you're comparing 495 with 500, so this is less. So the decision is going to be to reject the null hypothesis on question number 34. You're going to reject the null because the p is low and there is enough evidence at the 5% level of significance to support the claim. So you reject the null that is less than, and the other one is greater than. So that's your final answer, letter B. But you have to go through the hypothesis test to answer that one. So for additional practice, we have question number 35. Test the claim about a population mean, mu, at the level of significance alpha. Assume the population is normally distributed. So we need to assign the claim. So the claim was given to us as the population mean is not equal to 14. So the null hypothesis will be the one with the equal sign, and the alternative is the one with the not equal sign. So the claim goes to the alternative. So this is going to be a two-tailed test. Two-tailed test. So if you draw the null hypothesis, you have a two-tailed test, one positive, one negative. So, but if you look at the table, at the 0.05 level of significance, 0.05, this is left tail, right tail. So two-tailed test will be 1.96. So this is going to be negative 1.96, positive 1.96, and you're looking for areas to the left. So the p-value will be the sum of these two values. This is half of the p-value, and here is the other half of the p-value. So the sum of those two, or the product of 1 times 2, will be the answer. So I have to find the area under the curve. So 1.96, 1.9, and then you move over, this is 0, 1, 2, 3, 4, 5, 6. So this one is 0.9750. 0.9750 is the one. We're going to choose the negative one. I apologize. We're going to use the negative one because that is already to the left and I don't have to subtract. So I'm going to look for the intersection of negative 1.9 and 0.06. That's 0.0250. So this is going to be 0.0250. This one 0.0250. So the sum of those two, 0.0250 plus 0.0250, will give me a p-value that is equal to 0.505. So let's verify that. 0.025 plus 0.025 should give me a 0.0500. And if you notice, the alpha is equal to 0.05. So if the p-value is equal, if it is greater than or equal to, it's going to be that you will, so the sign of equalities is assigned to the equal bar, greater than or equal to. So the p-value will be considered greater than or equal to the alpha. So on question number 35, you're going to reject the null. I'm sorry, if it is less than or equal to, you're going to reject the null. So there is enough evidence at the 5% level of significance to support the claim. So on number 35, the answer is B. So when the p-value is either less than or equal to, you're going to reject the null. So when you set it up, so let me make a note so you remember that the p-value is less than or equal to the alpha, you're going to decide to reject the null. So now we're going to move on to question number 36. I believe this is the last one from section 7.2. Test a claim about a population mean. So here the claim is that the null, the population mean, is less than or equal to 19. Since you have an equal sign, you will assign that to the null hypothesis. And the alternative will be the complement of less than or equal to is greater than 19. So the claim was assigned to the null hypothesis. So here the alpha is at 0.01, and that will also help you find the z-score. So this is going to be a right tail test because the null, the alternative hypothesis has a greater than symbol. So you're going to go to the table, and again, this is a right tail test. So you look at the right tail test, levels of significance, 0.01, 0.01. So your z-score will be 2.33. So your z-score, so when you draw the normal curve, is positive 2.33. And then you're going to find the p-value. And since it is the area to the right, because it is a right tail test, it's going to be 1 minus the area that you're going to find for the z-score. So 2.33, 2.3, and then 0, 1, 2, 3 is 0.9901. So 1 minus 0.9901 will give you the p-value. So this is 1 minus 0.9901, and that is 0.0099. So your p-value is 0.099, and you're going to compare that with the alpha that is 0.01, and you should match the number of decimal places. So basically you're comparing 99 with 100 if you look at each one of the digits. So the p-value is less than the level of confidence. Therefore, we're going to reject the null hypothesis. So your decision will be to reject the null hypothesis. There is enough evidence at the 1% level of significance to reject that claim. So the right answer will be option A. And that's it for questions from section 7.2.